Chapter 7, Arrays Part 3. Some of us even remember that last video where I said it was going to be shorter and we're still reacting. It was 5 minutes shorter, but in fairness, I thought it was going to be a bit shorter, so I had a bit of a facepalm afterwards. I'm really just playing with my Stream Deck here. I could apologize, but it's going to be more of a sorry, not sorry situation. Because why? There's content that needs to be covered. That's important content. Speaking of which, let us jump right into this one. Write a program that will generate 100,000 random numbers, each between 1 and 10 inclusive. Your program should then count the occurrences of each randomly generated number. So here's what we ultimately want to get as an output. We want to loop 100,000 times. At every iteration of this loop, we want to generate a new number between 1 and 10, inclusive of 1 and 10. And then at the end of that loop, we want to have somehow saved the data to know how many 8s did I generate? How many times did I generate the number 8? How many times did I generate the number 7? How many times did I generate the number 1, 2, all the way up to 9 and 10? And here's the output. So we have number of randomly generated 1s, 10,016. Number of randomly generated 2s, 10,019. All the way to randomly generated 9s, 9,988. And then the randomly number of times we generated the number 10, 9,995, with this particular random set of generated numbers. So think about this, that we're generating 100,000 numbers, each between 1 and 10, and we're counting the occurrences. We should get around 10,000 of each, right? And that's exactly what you see here. So again, we're going to do a for loop. It's going to loop 100,000 times. Every iteration, we need to generate this random number between 1 and 10. And we need to keep track of how many times we generated an 8, how many times we generated a 4, a 3, and so on. So I want you to pause the video before looking at the solution and think of how could you do this? Of course, realizing that this is now a third video on arrays. How could you use arrays to help you solve this problem? There are many ways you could do it, some very inefficient, and then there are other ways which are ideal. So think of, we will need an array. What will you store in that array, and how could you ultimately solve this problem? Let me encourage you to pause the video, spend at least 5 minutes brainstorming, maybe even coming up with some code, and then come back to the video and see how that compares. I'll start coding what I think is a more correct solution, but I'll give some insight as to some inefficient solutions along the way. Come over here to our NetBeans. Let's make a new project, file, new project, next. And let's call this count what? Count occurrences randomly generated, this is numbers. That is a huge title. Let's just call this main down here. Cool. Let me zoom in so it can be seen here in the video. And let's start filling this in. Well, first of all, we're going to need a random, right? Random RNG equals new random. We're going to need to import this. And I'd rather do a wildcard import. Let's make this java.util.star. What else do we need to do? We need to loop 100,000 times. I'm not going to put a comma. 100,000 times. Each time we need to generate a new random value from 1 to 10. And we need to save that somewhere. So I'll tell you, there's a couple of different solutions you could have come up with. So we need to use an array. So someone may have thought to say, let's make, I'll put a comment down here. I'll type it right here. Make an array of size 100,000, saving each new random number into that array. And we will do that in this for loop. But remember, we need to then generate this kind of an output where after I've saved all those values, I need to somehow print out the number of 1s, the number of 2s, the number of 3s, and so on. So what would you have to do now? You'd have to loop back over all 100,000 values to count how many ones. And then you'd have to do it again to count how many twos. And then you'd have to loop over all 100,000 again to count how many threes, and again to count how many fours. We'd have to loop over that 10 times. That'd be 1,000,000 iterations to do all those counts. You could do that, but it would be super slow and super inefficient. So what could we do instead? I'll keep this here, just in case we want to revisit at the end that inefficient solution, but it would work. What can we do instead? Instead, I'm going to say make an array called counts of size, I'll say 10, but it's really going to be 11. So we're going to make an array of counts. What are we going to store in this array is going to be cool. What's going to be stored is going to be the number of times we have generated a particular value. So for example, I say of size 10, it's really 11, but for example, imagine we have counts at index 3. And let's just say that this was equal to 10,014. What this is doing is every time we generate a 3 randomly, when we're going to randomly generate a 3, we're going to increment the value stored at index 3. Does that make sense? We're going to increment the value stored at index 3 of this counts array. If we generate a 4, we would increment the value at index 4. So how would we do that? Ultimately, you're going to see we're going to do something like this. Counts at index 3 plus plus. And we're going to increment the value stored at those indices. And that's going to be how we can keep track of how many we've generated. So first thing, let's make this array. Counts equals new int. And I said here size 10. You could do size 10. But so if you generate a 1, you'd have to know we have to increment index 0. If you generate a 2, you have to increment index 1. That's fine. But I'd rather make it of size 11. If that makes sense here, that means I'm going to have counts at index 0. I'm also, I'll just put a comma. Sorry, I'll put a semicolon, just so I can close this off. I'll have counts at index 0. I'll have counts at index 1. I'll have counts at index 2. And this is going to go all the way up to counts at index 9. And then counts at index 10. So if it's size 11, I'm going to have access, I'll have indices in this counts array at index 0 all the way to 10. Now I'll tell you, this one right here, counts at index 0, we're not even going to use it because we're not generating any zeros. But why did I make it size 11? So I can just directly have access to the one index all the way to index 10, including index 10. It'll make more sense as we go through it. So we've made this array called counts of size 10. Let's also make a variable for our random index we are creating. So int random index, done. So what are we going to do? Generate a random index. I'll say generate a random number from 1 to 10. This number will be used as an index into the counts array. That's the idea. So random index is why I called it that variable name equals rng.nextInt from 1 to 11. Do recall that when we do nextInt with a starting point and an ending point, we have to go 1 past. If you did 1 to 10 right here, this would generate a number between 1 and 9 inclusive. So by putting 1 and 11, this will generate a number between 1 and 10. Cool. So now all I'm going to do is this. Check this out. Let's just say I generated an 8. Well, I want to be able to keep track that, hey, I found another 8. If I generated a 4, hey, I found another 4. Right? Let's just say that this was a 4. Here's what I've seen some students do. They'll say, okay, well, if random index equals a 1, counts at index 1 plus plus. else if random index equals a 2, counts at index 2, plus plus, I'll do one more, else if random index equals a 3, if you randomly generated a 3, counts at index 3, plus plus, and you can just keep doing this, checking if the random index was generated was a 4 or a 5 or a 6 or a 7 or an 8 or a 9 or a 10, and we'll increment that particular index of the counts array, right? We could do that, and that'll work. And do remember that when we create this array of integers called counts of size 11, every cell, every index defaults to 0. So we're just incrementing every time we find a 2, increment index 2. You find another 2, increment index 2 again. That works just fine. But check it out, you don't need to do that. Instead, we could just come right here and type counts at random index. If you get it, great. If not, pause the video and think of why that works. Whatever this random index is, we generated a number from 1 to 10. Well, if it was a 4, we're incrementing index 4. If it's a 7, we increment index 7. It's that simple. So I'm just going to type here a comment, increment the value saved at random index to indicate the value saved at index, random index is better worded, to indicate we generated a new number representing that number. Increment the value saved at index, random index, to indicate a new number for that value was generated. Something like that. You could probably word that a little bit better. Cool. That's now done. What remains is print the results. How do you print this? Well, we have 10 print statements. I need to print this number 1 all the way to the number 10. I'm going to use a loop. Check this out. And I'm going to loop from 1 all the way up to 10, including 10. So I'm going to make this less than or equal to 10. Why am I doing 1 all the way to 10? So I can literally just print these numbers in this column right here. And what do I want to print out? Let's use formatted printing. I want to print number of randomly generated blanks. Number of randomly generated %ds colon space %d new line. Perfect. And the first %d right here is going to print a 1, a 2, a 3, all the way up to an 8, a 9, and a 10. So that's just going to be I. That's the index I of this for loop. And what do I want to print? Number of randomly generated 2s, for example. How do I get this number? Well, that's going to be the counts array at index 2. Or more generally, the counts array at index I. Let's run this and see if any mistakes have been made. No, this works great. If you want to check if yours is working the same, remember that we can seed our random number generator, right? These random numbers are actually generated from, I call the random number generator like a tree that's growing random numbers. And the reason I say a tree, because every language uses the term seed. We can start our generator with a particular seed. So using the seed analogy of growing a plant or a tree, well, we have this random number generator that's growing numbers for us. I call it a random tree of numbers that are being grown. Well, if we all use the exact same starting point, the exact same seed, and we generate numbers, we'll generate the same set of numbers. So here we've made our random, and let us do rng.setSeed, and let's give it a starting point. How about 555? Super creative. So here, set the seed of our random generator to 555. We run it, and here is the result. So if I run it again, notice I'm going to get the exact same numbers because I'm using the same seed. So you should have these same numbers if you're coding it at the same time that I am. And let's even do this. You can run it 1,000,000 times. So now you should have around 100,000 of each. And in fact, we do. It's a nice even distribution of these random numbers. So back to this final comment, what another solution would have been to make an array, numbers, equals new int bracket 100,000. This is going to be horrible. We're going to loop 100,000 times. And each time we're going to just simply save into the numbers array at index I a new randomly generated value between 1 and 10 inclusive. So we're just saving all 100,000 values. Here, I just made an array of size 11, and I just ignored index 0, right, for the reasons already discussed. Here, I'm saving everything. So what's going to happen now? If I want to print those same results, number of randomly generated ones, well, that's going to be my I, but now I don't have this counts array. So what can I do? I'm going to have to somehow loop over this array numbers and count. It's going to be nasty. How about this? Count numbers I. That's just going to be a method that I'm going to have to go write. Quick and dirty method, public static int count int bracket number, oh, come on. It tries to autofill. Int bracket numbers, int I, and here we're going to do a int count equals 0, and we're going to do a for loop over numbers.length. And here, what are we going to do? I'm going to say if, I don't want to call that I. Let me just come all the way back. Here, I'll do this. Let's just call this value. And I want to rename this to I. I just like I with my for loop. Cool. So if numbers at index I is equal to value, so let's say we're looking for threes, we'll be checking every single one, trying to count up how many threes, count plus plus, finally return count. This is hideous, but if I now delete all of this and I run that code where I've made 100,000, and now when I want to print, I'm going to loop 10 times to print, but notice at every print statement, I'm having to call this count method, which is looping 100,000 times. It's nasty, but it's going to work. I've never coded it that way. It's going to work. But now you're actually looping, count that out. Each of these print statements, that's 10 print statements, each one calls this method, which loops 100,000 times. So that's 1,000,000 times. That's a lot more operations. Anyway, suffice it to say the correct solution is the first one that we showed. And this is a sample, another similar solution, where again, we're going to make this array of size 11. We loop 100,000 times. We merely increment that particular index, and then we print them out. It's a cool problem, a good example of a smart usage of arrays. Here's a checkpoint where it's really helpful to pause the video, study these two small programs, and try to make sure that we understand the output. I would encourage you to pause the video, code up the output, run it in your particular IDE, and make sure that you understand why you're getting that output. This particular one on the left, the real purpose of this example is just to demonstrate and highlight that we have local variables. When we call a method and we change a local variable, it's not affecting, it's not impacting main, whereas we can in fact change what is on the heap saved in our array, and we can do that from within a method. And this is doing the same thing as well. Just another reminder about what's on the heap versus local variables and that important distinction between them. Okay, we are, believe it or not, getting closer. Well, that's a given, but we're almost done. Searching an array. This is a very common task, searching through an array. You have an array of integers. You're looking for a particular value. How would you do this? You're going to use a for loop. You're going to loop over that array. Maybe the array is size 1,000. You're going to loop 1,000 times, right? And at every index, are you Bob? Are you Bob? This is now an array of strings. Are you Bob? Are you Bob? Yes, you're Bob. Great. Return true. We found Bob. Or you're looking for the number 379. Are you 379? Nope. Are you 379? Nope. You keep checking every index. Are you 379? Nope. Yes, you are. Perfect. Return true. What if you never find the value 379? What do you do at that point? If you never find 379, you need to then return false after you've looked over the entire loop, right? After you've looked over the entire loop, you return false and say, yeah, we didn't find it. This is the idea of linear search. We use a for loop to test every element inside the array, and we simply try to go look for that value via this for loop. So let's code this up in NetBeans, File, New Project, Next. Let's call this linear search demo. And finish. And so let's make this as a method. So public static Boolean linear search. And imagine we sent over an array of integers. We'll call it values. And we're looking for a particular value within this array. We normally call that a key. It's the key that we're looking for. That's a variable name that's usually common within most textbooks or from most publishers. Given an array, we're looking for a key. We're looking for a particular value. So all we're going to do is we're going to loop over the array, so values.length, and at every index, we're just going to check if values at index I, if it equals the key. If we found it, we're done. Return true. And that's it. That's the for loop. If you ever find it, return true, end of story. What if you never find it? After looking over the entire for loop, if you make it till here and have not returned, the value was not in the array, return false. Hopefully that's clear. That's the idea of linear search, and this is what we get. We return true or false to indicate whether or not we found the particular value in the array. But I want to tell you that it'd be better actually, instead of returning true or false, why not return where we found that value? Because when we return true or false, which is valuable, it doesn't maybe help us in from whatever method called linear search. Maybe main called linear search, and we return saying true, we found it. Well, what if we needed to print that value from within main now? How do we print that value? We don't know where we found it. So it's better to return the index where you found it, or if it was never found, maybe you could return -1 or any negative number to indicate that it was not found. So a quick little change, we could say return int as the data type, and instead of returning true, return I, the index where it was found. And if we never find it, return -1, which of course is not a valid index in a Java-based array. So this is doing the same thing, but now it's returning more valuable information, more actionable information that we can use within our main. And this is what we have here. So given this particular solution, if you were to trace this, given this list, 1, 4, 4, 2, 5, -3, 6, 2, given this array, we can now perform linear search. We send over the array itself, a reference to the address of that array stored where? Stored on the heap. And we send over, for example, the value 4. So what happens? It's going to check index 0. Nope, not found. Check index 1. Yes, it was found, so it returns 1. What if we look for -4? And -4, are you -4? Nope, 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 no -4. So it's going to return -1, indicating it was not found. And finally, if we look for -3, we're going to check here, index 0, are you -3? Nope, index 1, nope, index 2, index 3, index 4, index 5, are you -3? Yes, it is -3, it returns 5. Pretty straightforward. Here's an animation of what's going on. We have this array, we're looking for 3. Are you 3? No, 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 no. This is in a loop. Are you 3? No. Are you 3? No. Are you 3? Yes. and we could return that index. Pretty straightforward. We see that this is a slow algorithm because linear search, you have to search the entire array. Now, I'll tell you, if the array is not sorted, this is the best you can get. You can't get faster than that. Worst scenario, you must look over or through all values in the array. If I were to give you, 100 pieces of paper with student name, with a single student name on each paper, and it's not sorted by last name and first name, it's just randomly thrown at you, and I say, hey, can you go find the paper for Michaela? Well, how can you be sure that Michaela either exists or doesn't exist? If it's not sorted, you'd have to one by one look through all of these papers because it's not sorted, right? But what if it were sorted? If it were sorted, you could apply a different algorithm. Even if you've never studied algorithms, if I gave you 1,000 exam papers, alphabetized by student last name and then first name if you had two last names that were the same, how would you search for a student? I would hope you wouldn't start at the top of the stack and go one by one over 1,000 papers. What a disaster. What would you do? You might start about halfway, peek at that last name, compare it to the last name you're looking for, and then determine if you need to look in the first half of the exams or the second 500 of those exams. This is the idea of a better searching algorithm called binary search. And we're not going to cover the algorithm in this course, but I want to just plant the seed for what binary search is. It's a super fast algorithm that has a precondition that the array must be sorted. If the array is sorted, binary search is super fast. In fact, if you have an array of size 1 billion, imagine 1 billion, if it's not sorted and you're looking for a particular value in the array, worst case scenario, you have to look through how many values? All 1 billion. What a disaster. But if the array is sorted and it's of size 1 billion, you can leverage this search called binary search, which is super fast. And worst case scenario, using binary search on an array of size 1 billion, guess what? Worst case scenario, you only have to look at 30 cells, maximum 30 checks. I'm going to check that middle array, the 500th million, the 500 millionth, did I say that right? 500 millionth index in this array of size billion. I'm going to check the index 500 million, and I'm going to check the value. And then I'm either going to keep searching to the left, the smaller values, or to the right, the larger ones, dividing that search space in half every time. That's all I'm going to say on it, but it's a huge difference and it's super, super fast. And you'll see why I'm mentioning that, because I'm going to talk very briefly before we end the video, just a few more minutes, on this arrays class. Java gives us so many useful methods that are available for us inside the arrays class. The arrays class and the methods inside it, they allow us to sort an array, to perform binary search, to check if two arrays are equal by examining their contents, to give you a string representation of an array, and much, much more. Here's how we could sort an array. Given an array, you can sort that array by just typing in arrays.sort and then the name of the array. If you allow me, I'll just type up a silly, quick little example. Int bracket x equals new int of size 10. Let's make our random rng equals new random. We can set a seed, rng.setSeed. Let's set it to the number 10, so in case you want to use the same seed so you can follow along, get the same numbers. Let's do a for loop, and in this loop, let us generate a new value, x at I equals rng.nextInt. Let's put a number from 50 to 100. Let's now print this array. Okay, it takes longer, but you get to watch me code it, and you can see you can code it fast. Public static void print array int bracket. We did this one last time, ARR, and we're just going to loop over the array, ARR.length, and we're going to print at every step of this iteration, we're merely going to print the value. So I'm going to call it, let's do formatted printing, and I'll call it ARR at index %D equals %D new line, comma, this is going to be I, and this is going to be ARR at index I. Cool. Let me run this after I do print array of index X, of array X. I'm sitting over. This is what I get. That was too quick. Hope you followed along. This is what I now get. So what I'd like to do is now sort this. How do we sort it? Arrays.sort, and I just type in X. And now let's print this again. Print array X, and let's see what we get. And I didn't put a semicolon. Big brain. That is a big brain moment. I love big brain. Did not put a semicolon. When we run this code, we see I get here from 0 to 9, the originally randomly generated array, those values, and now we see that it is sorted. Did you need to see me showing you how to sort that? No, you could have just trusted me, but that's sort. We also have parallel sort, which works faster and more efficiently, assuming that we have multiple processors, which many of our computers do. Here's an example of binary search, that if the array is already sorted, instead of doing linear search, we can actually do binary search. So in fact, if you just type in arrays dot, you're going to see there are many methods. Look, this is just an example. I listed out just a few examples of sort, binary search, and others, but there's so many methods in here. Fill. You can fill your array with certain values. Mismatch, parallel sort, sorting. So many things you can do that Java gives you these methods to help you with your arrays. So here's an example of binary search given an array of integers. It's just showing you how we can call arrays.binary search. We send over the address of that array on the heap. We send over the value we're looking for, and it will return for us the index where it was found. Content equality, given two lists, we can use this dot equals method, also found within the arrays class. Now again, these are all static methods. These are service level methods that are provided for you in the arrays class, just like the math class provides you methods. Well, these are methods inside the arrays class that provide a service, some functionality. And here's the equals method. Given two arrays, we can access, or we can use this equals method in the arrays class, and we can send over to that method two addresses or two references of two arrays on the heap, and it will actually check for us the contents of those arrays to see if the arrays are equal. As we know, given two arrays, if I were to make two arrays right here, int bracket A equals 1, 2, 3, int bracket B equals 4, 5, 6, I can't check if those are equal by saying A equals B. Pause the video. Make sure you know why. Why can I not check for equality and for A equals B? The answer is going to be false there, by the way. It's going to be false. But why is it false? Not because the arrays aren't the same. It's going to be false because the address is not the same. I'm going to hit run here, and notice it's still false even when the contents are the same, because this is an array on the heap, and this is a new array on the heap, even though it has the same values. But they're two different arrays, two different addresses. This is just checking the address. So how do we check the content? We can use that arrays dot equals. So arrays dot equals AB. And I have an extra parenthesis, and now we get true because it's checking the contents for us. Super cool. Final thing, we may have noticed, I certainly hope we've noticed, all throughout these videos, we have seen this public static void main. What is inside this? Inside main, we see inside main as a parameter this. Well, now we know what that is. This is an array of strings, happens to be called args, standing for arguments. So I can actually just print out, I can loop over args.length, and I can print out each of those individual arguments, args at index I. So the main method, which is your launching point for any Java program, it actually receives as a parameter an array of strings that is just called args for arguments. So you can, when you launch your program, when you run your Java program, if you were to send to it an array of strings as arguments, which you might think, why would I do that? That's a different discussion. But if you were to do that, you could print out those arguments one at a time. Now, how can we do this within NetBeans? You actually have to come to your, this is my garbage, right? You need to right-click on your project, you go to Properties, and then you come to Run. And then here, I've already listed out some arguments. Watch, I'll hit OK, and I'll run this code. And here we go, it's one at a time. Let me change this again. Right-click, Properties, Run. I'm going to come to Arguments, and I'm going to say, this is super funky and weird. Weird, period. And I hit OK, and I run it. This is super funky and weird all on one line. Weird, but it's something that we can do. Guess what? We are done. Let's go. 36 minutes and 47 seconds. I want to wait 10 more seconds just so we can get to 37 minutes. It's been fun. As always, reach out if you need anything. Leave a comment, post questions. Take care, everyone.